All right, so we're gonna go with vertical and horizontal asymptote. Like some parts, these things will be given to you. Okay. All right, so you can tell that from this graph, definitely there's a horizontal asymptote and vertical asymptote, right? Now remember, horizontal asymptote, it looks like this, right? Kind of like a straight line will be horizontal asymptote, and vertical asymptote will be like that, right? I hope you guys know. All right, so doesn't it look like we might have a vertical asymptote over here someplace? I'm using my mouse, but it's not very straight. I hope you guys can see that, right? Are we okay with that? Just pay attention. And then I'm recording this so you guys can watch the video later on. And then doesn't it look like there's another vertical asymptote right here too? If you click on your delta map, you're gonna get different questions. Can someone tell me where the horizontal asymptote might be? -1. I think someone said it right here. -1. Does that make sense? All right, so we're gonna clear this. So we have total of. Looks like we have total of how many asymptotes? They're saying including vertical and horizontal asymptote. How many asymptotes do we have in total? We have 3. Right? And then it says your horizontal asymptote, well, you can be like vertical. It doesn't matter. You can change it. Your vertical asymptote might be where? The closest number from your graph. -2. Very good. -2. That's pretty easy, right? Because look at this. As you're approaching to -2, you're going down to the. Do you see it? As I'm getting closer, remember we're getting closer from both ends, right? Do you see it? We're getting closer and closer to -infinity. Do you see that? And then from the other side, we're getting closer and closer and closer to -infinity. Do you see it? So because as x is approaching to what? Which one would it be? -2. Is it this one or the last one? First one, -infinity. All right, so I'll help you guys. All right, you're okay with that. So if you understand that, let's go to the second part. It says, let's do vertical again, okay? Since we have two verticals next to each other. So where's our other vertical asymptote? 6. Very good. Because you tell me now. Which one? Okay. As x is approaching to 6 equals to -infinity. Very good. Excellent. All right, now let's look at this right here. Do you see this horizontal asymptote is this way? All right, so then it is horizontal asymptote at -1. -1. Make it smaller so we can see it. All right, I think that's a little bit better. Okay, so -1 because yeah, you're going towards. Do you see we're going towards positive infinity? Where limit is going towards positive infinity, and it is equaling to -1. Does that make sense? Okay, how many of you guys follow what I just did with that? All right, very good. Now again, you can watch the video over again, and that should be correct. Let's submit the answer just to make sure this is correct. Oh, thank God I got it right. Okay, so let's go back. All right, so these are limits to infinity. All right, so now this is where you need to use your graphing calculator, kind of. All right, but there is a shortcut. Okay, but you know what? Let's do another problem because this is so complicated. I mean, you guys can figure out. Come on, give me a nice one. Give me a nice one. Jesus. Okay, well, whatever. God. Okay, I'm just gonna go with this. All right, go ahead and graph this out for me, please. I just couldn't find anything else, but it doesn't really matter. I just didn't want you guys to start with a really complicated one, but I guess they just have complicated ones. All right, so let me pause this since you guys are graphing. All right, just in case, if you don't know how to use your graphing calculator, you need to put it as a fraction. How do you put it as a fraction? You have to go to math, and then move it over to the fraction, and then press enter, and then you get that fraction right there. Do you see it? All right, now this one, I need to minimize it so I can see it. All right, so I have parentheses 4x to the power of, what is that, 2. And then minus 1. Again, if you're having a hard time with your graphing calculator, I'm showing you how to put it into your graphing calculator so you guys can check later. 2. And then plus 4. Alright. We have parentheses, 5x to the power of 3, and then plus 2, and then close the parentheses, and then parentheses, 2x plus 5. Yeah, I want to double check this. Oh shoot, I didn't even do it right, huh? No one even stopped me. Delete. 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 You guys need to stop me if I'm making a mistake. It's okay. Alright, so this is parentheses, right? 2x plus 5, and close the parentheses. Alright, is that what you guys have? You're still typing? Okay, so once you have something like this, if you graph this, alright, so I can zoom in. It looks like the window is a little bit off for me. Okay, so I can zoom in. Zoom into standard. Remember, zoom and then go to standard. Let's learn how to use your graphing calculator. Oh, that's beautiful. Okay, so it looks like we have a horizontal asymptote. Do you guys see? Do you see this horizontal asymptote right here? Do you see it? As we go out towards this way, do you see that? We're getting, if you look at your graph, we're getting closer and closer to some value over here. So can someone guess approximately what that value might be? Like as I go out towards this way, 2. Very good, 2. The answer should be 2. So the answer is 2 here. Now, there is a shortcut. I want you to look at your equation right here, your algebraic expression, rational function. Do you see it? Can someone tell me how to get 2 really quick without actually graphing this? Anybody know? You see anything? What's that?
With the highest powers in the top and the bottom.
Yeah, so you want to take the highest power. If you take the highest power over here, if you multiply this one with this one, just take the highest power. If you multiply them, you get 20x to the 4th power. You see what I just did? Over, take the highest power here, and take the highest power there. If you multiply them, what do I get? 10, I get 10 x to the 4th power. And then you can kind of reduce this, cancel this, and then reduce 20 over 10. What's 20 over 10? 2. That's a shortcut. Okay, how many of you guys follow what I just did with the shortcut? Okay, now you don't need to use a shortcut. You can always use a graphing calculator. Do you see that? Right? You can graph it out and see, but sometimes you can't really tell what that number might be. But if you want to double check, you just need to take the highest power from each one and then just do that, okay? All right, so should we practice with the next one? Let's see. Clear the screen, back. All right, new problem. All right, look, what's the highest power? Isn't it just this one? But make sure you multiply -10 with that. So this is -10 x to the 2nd power. And which one is the highest power in the denominator? 7x with 4x. So what is that? 14x x squared. And you can tell that x squared will cancel each other out. That will give you negative 5 over 7, isn't it? Doesn't 10 over 14, isn't that reduces to negative 5 over 7? Alright, well I hope so.
How is it 14?
Isn't it 4? Oh shoot, because I don't know how to multiply? That's why you didn't answer the question. It's 28 because I don't know how to multiply numbers. So if I reduce that, that will be 14 right here, right?
Yeah.
That's why you guys didn't see anything. Alright, so it's 5 over 14. So let's go ahead and put that in. Let's see if this is correct. I hope so. I hate making mistakes, and especially I'm recording it. God. Alright, so don't say anything, okay? Alright, so what is this? Negative, right?
Yeah,
Negative 5.
-5.
Negative 5 over 14. And then submit. Alright, there it is. Check. Alright, again, do I need to know how to use a shortcut? Well, I mean, it would be nice, but you can always use a graphing calculator. Do you see how a shortcut could be really useful? It doesn't mean that your shortcut will always work. Sometimes it doesn't cancel out nicely. If it doesn't cancel out nicely, then you might want to check with your graphing calculator. Did you guys understand that? Okay, good. Let's go to the next one. All right, so this one is, again, you can use your graphing calculator to see what's going on. So let's go ahead and use your graphing calculator to see what is going on with this graph. All right, so let's go ahead and turn this on. On. Y equal to clear. Can you see it okay? God, I wish I had that program. I'm so disappointed now. Alright, so let's go ahead and put this into your graphing calculator. Make sure you put negative, not minus. Negative x to the 5th power and minus 7x to the 4th power. Again, you can use Desmos if you feel like Desmos is easier to use. Let's go ahead and graph this. Alright, so let's see what's going on. You can even use Zoom Fit if it doesn't you see it Zoom Fit, if you go all the way down, it will kind of, like, calculator will determine how wide the window should be so that you can see a better graph. Okay, so looks like my graph, if I look at this, you can't even see it, can you, huh? Can you see it a little bit better? Can you see it on your screen? It's not all that good. Sorry. Alright, so it should look somewhat like this. If you look at it, it kind of goes like that. If you use Zoom Fit or Zoom Out, okay? Alright, so what happens to this graph as you go towards positive infinity? So that means as we go out, I'm going to use a green color, as we go out this way, as I go out towards that way, I have to follow. What happens to my graph? It's negative infinity. So you would have negative infinity right there. Okay, how many of you guys follow what I just did with your graph? Do you see that? Okay, but there's a shortcut for this as well too. I mean, I want you to look at this function. Why do you think we're going to end up with negative infinity? You take the highest power again. Do you see this highest power right there? So if you think of it as a highest power, this is just negative parentheses. What do I need to plug in for x? Because it says what? X is getting close to infinity, so this is infinity to the 5th power. Oh, I know what. Okay, I can make it, you know what, I can fix this. I'm so happy. Alright, there you go. If I darken the screen, it shows a lot better. Alright, that's nice. Okay, so, alright, so how many of you guys understood what I just did with the shortcut? Nobody. Alright, so let me show you another one. Not with this one. Okay, so look at this. The shortcut, you can graph this, okay? But the shortcut is basically you can plug in infinity into x. So this is e to the power of infinity. So what do you think? Anything to the power, e is 2.77. So what is 2.71 something to the infinity power? What do you think you're going to get? Infinity. Don't you going to get a very, very big number? So the answer right here will be infinity. But we can see that. Let's go ahead and go to your graph. If you compare that, this is e, second e, which is that, to the power of x. And then let's graph. Again, my window is off, but I have to fix it. So how do I fix my window? You go to Zoom, go to Standard Window. Alright, you just have to play around with your graphing calculator. Do you see what I'm doing? I'm just changing the window so that I can see my graph better. Alright, so what's going on? As we are going out, like my graph kind of looks like this, right? Doesn't it look like that? So as I go towards positive infinity, that means to the right. As I go to the right, like this, what happens to the graph? Goes up. Okay, so again, if you don't understand the shortcut, then is it okay to just use your graphing calculator to see what happens towards the end? Yeah, it's very easy. Okay, good. So that's that. Okay, so these are horizontal asymptote. You can use your graphing calculator to figure this out. So I'll let you play around with your graphing calculator for that one. Now this one is a little bit harder. All right. I know that piecewise function, that can be difficult, but it doesn't mean that it's going to go away. Because once we have our book, you're going to see a whole bunch of piecewise functions. These are piecewise, okay? Right, so I actually wanted to get to here because everything else was fairly simple. All right, you guys ready? Here we go. So I want you to think about, I'm going to use a red color. I'm going to use a red color to graph this one right here. Can you visualize this function right here? Can anyone visualize this function? What is that? What shape is that function? Okay, if you can't visualize this, what should we do? Graph it. All right, let's go ahead and graph this out. Clear this. All right, so go ahead and put negative x squared. Stay with me, okay? And then make sure you practice using your graphing calculator just like me. And graph this out. Very good. All right. So how many of you guys knew that was a parabola? One person? Oh, okay. So it is a parabola. It looks like it is coming down this way like this, right? But I don't keep all of them. Like I have to erase part of it. I don't keep this whole thing. Because this right here, this is telling you to keep the certain portion of it. Do you know which portion we need to keep? Can someone tell me which part we need to keep and which part we need to erase? What does it mean by x is less than or equal to 3? So do you see this graph right here? Do you see this 3 right here? You need to imagine that there is a wall right here, and we need to delete everything on the right side of it. So imagine that there's a wall right here, and we need to delete everything on the right side of it right here. And we keep everything on the left side. Now, once I erase this, I need to have either a big open circle here or a closed circle. Anybody know if we're going to have an open circle here or a closed circle there? Closed. How did you know it was closed? Because of the inequality right here. So this is closed. Like that. Alright, now second part. Alright, let's go ahead and graph this one. I'm going to use a blue color, no, not blue, purple. We're going to use purple color to graph this one. Anybody know the graph of this equation? What would that give you? Anybody have an idea? Okay, someone said it, I think. It should be a linear line. So let's go back and clear this. And then put -9 plus 2x. And graph. Alright, so we get a line like this, but I don't keep all of it, do I? I'm not going to keep all of it. Which part do I keep? This will tell you. Do you see this 3 right here? It's going to be down here, right? And then we keep everything to the right and everything else, so down here someplace. And erase all of this. And we only keep this part right here towards the right. That's what we're going to keep. And I don't know if this is connected or not. It might be next to each other or not. But I can tell if I graph the other one. All right. Okay. So, first of all, I want you to learn how to practice drawing piecewise function. All right? It takes a little bit of practice. But there is a shortcut to this. Okay? I know that this was pretty hard to follow. But I know you guys can do this. The shortcut is this. Remember that limit? You need to check both sides, right? Limit, we need to check both. So this is saying we need to check limit from which side? From the negative side of the 3 and positive side of the 3. Out of these two, which one is the left side? Top or bottom? Which one is the left side? Top. How do I know? Because of this. This is your left side. I hope you guys are understanding what I'm telling you. This is a shortcut, okay? So I need to check left side. So I just plug in 3 into that one right here. So what is -3 squared plus 9? Plus 6. What is that? Isn't that -9 plus 6, which is -3? All right, now I need to check the right side, which is this one. This is your right side. All right, I need to plug in what value here? 3. So -9 plus 2 times 3 will give you what? What does that give you? -3. All right. So what do you notice about the left side and the right side? They are matching. They're matching. So if they're matching, do you have a limit? Yes. What is your limit? -3. If they're not matching, do you have a limit? No. Then limit does not exist. Okay, how many of you guys understood the shortcut? Raise your hand. Okay, very good. You can watch the video over again. That's without actually drawing any piecewise function, okay? But I do want you to practice drawing piecewise function. It's important later on. We practice now so that we don't get behind later, okay? But there is a shortcut. This is it. All right, very good. we're going to move on. Okay, here we go. This one. All right, these are all factoring. Okay? So for this one, first you want to start with a direct substitution. Let me explain direct substitution here. Alright, we're going to start what is called a direct substitution. Alright, so this is called a direct substitution. Sorry. Alright, these are all shortcuts. First, we learned there are different ways to find limits. Alright, so finding limits. First, we learned how to use a table. Did we use a table from the Delta Math? You plugged in like 1.9999, 3 point whatever, right? So that's a table. You can always use a table. Number two, we can use graph, right? We learned how to graph it out, like Delta Math actually gave you the graph and you approach from the right side and the left side and so on. So number three, we use what is called direct substitution. Now, direct substitution, it doesn't mean that it will always work out. Usually, direct substitution, you want to start with the direct substitution, but you'll notice that most of the time it doesn't work, half of the time. So you need to come up with some other way. If direct substitution does not work, then you want to use what is called simplifying method. All right, what is simplifying method? Basically, simplifying method is more of a factoring. That's why we use, or we learn, or practice factoring for the last 2 weeks. Okay? Because factoring is important. Okay, so let's see. Look at this example. So we have a limit. X is approaching to -1, -5x minus 5, and then 2x plus 2. All right, just stay with me, okay? Just stay with me, and then you can copy this. I'll give you time to copy this later. You can watch the video over again, but just make sure you just stay with me. All right, I want to start with direct substitution at all times. So what does that mean by directly substitute? You just take this -1 and plug it into x and plug it into x. That's all it means, okay? Direct substitution just means directly substitute. So this is limit. X is approaching to -1. -5 times -1 minus 5. This is 2 times -1 plus 2. All right, let's see what happens. This is +5 minus 5 over -2 plus 2. All right, what happens? This is 0 over 0. Anybody know the answer to 0 over 0? It's not 0. Okay, put 0 over 0 in your calculator. What do you get? Huh? Yeah, you get error. Or we get undefined. So undefined error is no good. This is bad. Why do we get undefined or error? What's the issue? Anybody know what the issue is? 0 you can have on the top as 0. Do you see the 0 in the denominator? That's the issue. You're not allowed to have 0 in the denominator. So that will give you undefined. Okay, so can I use direct substitution for this particular problem? No. We cannot use direct substitution for this particular problem. So what does that mean? We need to find other ways. I can use a table, which will take too long. I don't like to use table. It's just time consuming. We can use graphing, but what if I don't have a graphing calculator? I don't want to use graphing either. So there should be other ways. Does that make sense? So what's the other way? It's called simplifying method. So we don't use a direct substitution, right? So let me rewrite this again. Limit x goes to -1, -5x minus 5. Again, stay with me, guys, okay? You just have to stay with me and focus and make sure you understand each step. Do you see anything that we can factor from the top? -5. Very good. We can factor out a -5. What's left over if you factor out a -5? X plus 1. Very good. It is x plus 1. You just have to redistribute to make sure you get -5x minus 5. All right. What do you see in common in the denominator? 2. If you factor out a 2, what do you have left over? X plus 1. Okay, do you notice anything? Can I cancel anything? What can I cancel? X plus 1, x plus 1. What's left over? -5 over 2, and this is your limit. Do you see how we factored and simplified by canceling and, right? Okay, how many of you guys follow what I just did with simplifying? Excellent. Let's try another one. Eventually, I want you guys to use just shortcuts all the time. Okay, but first you need to understand what's going on. Alright, so again, you can watch the video over again, but anybody need more time with that simplifying method right here? Anybody need more time? No? No? You do? Okay, go ahead. Alright, let's think about this other problem on the right. Let's see if you can use simplifying method to simplify this. Go ahead and try it on your own. Alright, since a couple of you guys need more time copying this. Alright, so try this problem on the right on your notebook, piece of paper. Try it. I'll give you about a minute. Alright, so can someone help me with this one? Is this factorable on the top? Anybody? Yes. What is it? X times? Okay, x minus 1. Okay, yeah, say it. Okay, what about the denominator? Is it factorable?
Yes.
Yes. What is it?
5.
5 times
X minus 1.
x minus 1. Very good. So can I cancel anything? Simplify.
Yes.
Yes, you can. You can simplify and cancel. Which ones can you cancel?
Yes.
X minus 1 with x minus 1. So what do you have left over now? Limit x goes to -5 x over 5. Now, can I use direct substitution?
Yes.
You can use direct substitution in the beginning or towards the end. It doesn't matter. We simplify to make it easier, and then we use direct substitution. All right, what number do you substitute? -5, whatever this number is. You directly substitute this number. So what is it if you plug in -5 over 5? -1 is your limit. Okay, how many of you guys got -1 on your own? Oh shoot, 3, 4 people, that's it? We're in trouble. Let's try another one, okay? Alright. I'm gonna pause this.